I'm trying to solve a problem. You see, there's this whole field called computational neuroscience. And in this field, a lot of people are trying to simulate neurons. Neurons like the ones you find in the brain, not the ones you see in AI models, etc. Like real neurons, trying to replicate the way they look, the way they act, everything, their shape, their dynamics, etc. And the field has been around for a little bit, probably half a century now. And people have been doing simulations since the 80s. Um, Unfortunately, computational neuroscience has never had a really great, fun, interactive way to view their simulations. What you see here is my attempt at doing that. So we've got this window where you can track the state of parts of your neurons. So right now we're tracking this little bit. You can click anywhere and just track that variable. In this case, we're tracking voltage. Um, and yeah, you can just sort of keep up with whatever's going on with your neuron, um, and interact with it in real time, sort of make a toy out of it. Um, yeah, and so we're gonna get into just why um, computational neuroscience is lacking this. And we'll see if we're really solving the problem here or not. So let's get started for a second by taking a look at what has been historically, back in the day, state of the art. Um, let's take a look at this example that I'm going to run here. One of the main simulators for computational neuroscience historically has been called Neuron. And Neuron has existed from all the way back in the late 80s. And and its UI, well, it kind of shows that. Its age certainly shows. So it is pretty good. If you take a look here, I can open up a shape plot. And so you can see the UI, the options you have here in the UI are quite extensive. A lot of different tools and graphing and everything, and you can do that while your simulation's running, so that's pretty good. And you get this great little window, so let's take a look. We get the same cell that we saw before, same neuron, which is pretty great. I mean, the issues start here, right? So you're faced with this window and you try to move things around and nothing happens. So, okay, well, what do we do? Well, we can, first of all, let's get a better view here, zoom in and out. Okay, so that works pretty well. That all looks well and good. It looks a little different from our cell because it's not plotting the diameter of all the pieces of the cell. Okay, that's not too bad. We can do that. Okay, things are starting to chug. Zooming is not as nice as it used to be. Let's try rotating. How do I even do that? Well, you gotta click on this button. Oh. And now you can really see, you know, the age of this UI in action. Now, I think this UI was made, I don't remember when, 90s, 2000s. But it was back before we had the good graphics stuff. And so, well, I haven't clicked anything in a minute, but we'll let it sort itself out. In the meantime, you can do a lot of other things. So how do I get back to that window? Well, of course, naturally, well, I have to wait for this thing to finish doing its thing, um, which is kind of funny. It just simply won't let me do anything. And finally, we're back. Cool. Well, with that out of the way, ooh, that is chugging. Okay, let's grab this. And yeah, of course, this hides behind that naturally. Okay, we're going to, well, the nice thing is that we can run our simulation however we want. One thing that we can see here is we can actually plot the voltage however we want. So we can hit this plot what, which of course is very obvious to everyone. Hit the V, which is of course very obvious to everyone. Oh, just kidding. We're doing, first we need to do shape plot. How could I forget that? All these things very intuitive, very obvious. And then we are going to go to the run control. So this is our simulation. So that's kind of nice. You can rerun your simulation here. And to do kind of what we were doing before, we'll hit the movie run. Now the movie run basically, of course, opened a window on my other monitor. Fun. Movie run is that thing that lets you run this over time and you can watch it happen. So it should look kind of like what we had before. The colors are a little different than my colors, but that should be okay. And you can watch the time chugging along. And eventually, you should see the same thing. Neuron starts spiking. Hey, why don't we try to rotate around while we do that? Ah, yeah. Yeah. Now, I will say not all cells are as, you know, bushy and rich and complicated and have as many sections as this one, but this is a bit of sort of a stress test on this whole thing. And boy, is it stressed. So this has been the tool that a lot of people have used for live visualization, and not to completely discount it. I mean, it can do a lot. It's just really old, and that's very obvious. So, okay, let's quit out of that real quick. That's one of your options if you want to visualize things. Let's try something else. Let's try one of the modern plotting libraries. Now, I did this a little wrong for the sake of just demos. In fact, it's quite hard to get matplotlib, which many of you may be familiar with if you're Python data people and you plot things. Um, this this won't exactly plot things. You see, it doesn't plot individual bits. It plots it all as one connected line. And so it's going to look a little weird, but for the sake of demonstration, it doesn't really matter. And in fact, the performance gets worse if you try to do it that other way, at least as far as I can tell. So I'm going to run the little matplotlib example. Here we go. And you get matplotlib, but you lose quite a bit. In fact, you can't really, it's not easy to run a simulation and watch it. You can do some animation things, but it's very slow, very chuggy. On the bright side, you can finally rotate. Zooming, not as great. The matplotlib zooming is quite funny. You gotta do a little lock here. And then I have to unclick it and then look around. It's strange. Strange to say the least for neurons. Okay, so that's one option. Yeah, it's hard to do simulations and watch them. The interactions are weird. And of course, you can't actually click anywhere on this neuron and get information. That's just stuff you're going to have to do in code. Okay, cool. That's matplotlib, one that we're familiar with. One that you might not be as familiar with is Plotly. Plotly is another library for plotting, and it's a bit newer. Can open things in web windows and such. Let's take a look at what Plotly can do for us. Is it any better? Well, okay, this is something. Certainly better. Now we're back to the problem of we can't show the widths of all the little bits. And so that's a bit of a downside. It's not an easy thing to do as far as I could tell from the docs, but probably possible. But once again, you can't really click on anything. You can save some animations or connect them to sliders and try things, but certainly not that interactive. Although I must say it's quite attractive to like see. Ooh, I just rotated things. Whoa. It's pretty cool. I will say Plotly is sort of like what a lot of people will use, at least for visualizing their morphologies. You can also just like freeze your simulation at a certain point and look at it. And so there's options. And Plotly is pretty modern, pretty new. But once again, I can't interact. A lot of things will have to be done in code, or I can add sliders, but it's not it's not exactly there. What I want is like a full-on toy, like a full-on thing that I can just play with my simulation and just see what happens. So that brings me back to my library that I've been developing over the past month or so. And yeah, we're going to take a look at that now. So to show you what I was doing before, it's not very much code. You do need to write a class, which is kind of annoying, but it wraps a lot of stuff. So, a lot of work went into making this look very straightforward. Basically, all you do is in the setup, you do a lot of your simulation setup as you would normally in Neuron. Now, the other thing that I tried to do with this library is actually make it more generic. So Neuron isn't the only simulator. There's other simulations. So Neuron simulation is a particular example, but simulation, the generic class, should work with other things like Jaxley and Arbor and NetPiny and other simulators you may have heard of or may not have, but they exist. Moose is one of my personal penchants. So yeah, it's not a lot of code, and if we run this guy, we can now, in contrast to all of that stuff, see kind of what we gain by doing this. So let's take a look. Oh, I guess I should also add one little friendly addition, Arbor GUI. So the Arbor simulator has a very specific GUI they developed. It only works on Mac and Linux. That's kind of a downside. It's not a Python package. Um, it's its own like thing made in OpenGL, and it is great. It has a lot of stuff in it. You can paint your ion dynamics. These are all things I'd really like to add to my simulator stuff. Um, Sort of give you more of the setup, but I also don't believe, yeah, it doesn't actually let you run the simulation. It just lets you look at the neuron, I think. I'm not sure. Maybe it does do the simulations, but it's yeah, I don't know. Might as well look at the tutorial real quick. Morphology, locations, setting up the simulation, running simulations. Oh, well, that's not. I mean, can I not see? Anyway, you can see there's issues with just about any simulator um, that's going on. Oh, I should add some credit to Dendro Tweaks. These guys are trying very hard to make a sort of cool web interface for things. It is web, and I think that again, the benefit of what I'm doing is that it's fully a Python package. Nothing crazy. It is a Python package, but this is nice. You do have this cell view. You can click on sections, see data on them. This is another thing that I'm sort of inspired to consider. You can also see how all the sections are connected to each other. It's very cool. I kind of really enjoy uh, generally what it looks like, simulation. Um, you can do a bunch of stuff here as well. So shout out to them. You definitely do have an attempt here, but I'm really trying to make a toy. I'm trying to, um, let's see, I don't know, I run protocol. It's a single recording at the Sona. Anyway, there's a lot of stuff here that I just felt unsupported protocol. Okay. Anyway, there's a lot of stuff that I felt we could make this just a bit more intuitive, a bit more straightforward. So this looks a lot like your normal neuron code. The only thing it doesn't have is the simulation stuff, which in terms of stepping the simulation forward and running it and all that, we kind of hide that in here. and in a variety of other places. But this means that you, as the simulation person, can just sort of focus on loading your morphology, setting up the dynamics you want, and the mechanisms. Hodgkin-Huxley is one of the most common ones. We have it inserted here in every section. And set up some current clamps. This will stimulate the neuron at various times. And that's it. And then you can just run the thing. And I'll show you what that looks like again right now. So here it is. It takes a second to load for sure. This time it took about 7.7 seconds, but that's for one of the hardest cells. I think it doesn't get much worse than this one. And you can see you get your simulation. Right now we're recording from this region. You can click over here, and now we're suddenly recording this dendrite. And every 20 seconds, I have it set up to send a pulse. So waiting for 20 seconds, we'll see the pulse starts here, propagates down, and as it arrives, you can watch it here. And so that's pretty awesome. The idea is basically just to make this a toy, and you can just add controls like spacebar, in this case, reset simulations. And so you can do that nice and easily. And the idea is to adapt all the best parts of all the simulators and visualizers that you just saw here and put them all in one big Python package where people can just play with their models without too much work. So hopefully that will happen soon. I will show you one more demo that I think is more exciting than the single cell. And it is my favorite thing, which is the nematode. If you don't know, there's this nematode that has been one of the model organisms in neuroscience. It has 302 neurons all together in its whole nervous system. So here's the whole nervous system. Boom, boom, boom. All I'm doing is stimulating every single cell body. Now, again, the actual mechanisms in place here are not realistic or anything, but it's to show you that you could just visualize this whole thing running at the same time. You can click any region you want and get the data that you want. Here's the axon. Very exciting stuff. And so this is really a generic simulator. If you look at the code for that section, it's really not too different. I just load more cells. I do pretty much the exact same thing other than stimulating every soma. But again, these are all really straightforward things that anyone who does neuroscience simulation would know how to do. And so hopefully as I develop out this toolkit, people will be able to really kind of generically play with their simulations and learn things. One kind of very interesting thing to me was simply that you can actually see that certain regions don't get activated at all, and they're these far away dendrites. And I don't know why that is the case, but it gives you some insight as to maybe things are not getting hooked up correctly. Maybe simulation's screwy. This would be very hard to figure out without a tool like this. So yeah, I'm gonna now plug the GitHub. Check it out right here, departmental neuron GUI. I'll add the link in the description. And yeah, instructions here. It's all trying to be a big pip package that you can just pip install. You will need Python 3.11 plus. There's just a constraint I have on some of the packages that I use, but other than that, it should be as simple as that and running the examples. So check it out. If you are interested in computational neuroscience, this is a great way to start playing with it and get a little bit of intuition for what's going on. I guess one extra step here, you do need to install the simulator itself separately, Neuron. The visualizer stuff is here. There is a way to do it via the package, but it's probably easiest, especially if you're a Windows user, to just install Neuron separately. Yeah, that's all. Check it out. Let me know what you think.